Okay, hi there. My name is Andrea Morgan, and I'm instructor with the Simpson County Literacy Center. And I know many of you are working on your HiSET exam, and with the national emergency that we're all experiencing, I just thought I would throw some instructional videos together and put them on the website, send them out via email and text messaging so that you could continue your learning and continue to make progress during this time of social distancing. So first of all, I pulled 5 math problems from the website, the official HiSET website, which is hiset.ets.org. So these are not my problems. They came from the website. And I'm just going to go through them with you so that you can understand the math concepts related to these problems and some methods for problem solving on the HiSET exam. So let's go ahead and get started. And I'm going to go ahead and share my screen. Okay, so I believe that you should be able to see the problem here in front of us. So again, this problem came from the HiSET website. This is one of the 5 sample math problems that they've provided. So let's go ahead and read this problem together. It tells us that Kyle purchased a padlock with a resettable combination that uses 3 digits from 0 through 9 that must be entered in the proper order. A digit may be a combination. So which expression shows the total number of possible combinations for the padlock? Okay, we've read the problem, but if you're like me, a lot of times that first read through, you kind of get a sense of a few ideas. There's a padlock, there's a dude named Kyle, there's digits. They're asking me for how many combinations of digits there could be, but I'm not sure that I really understand well enough to put together a plan for solving this problem. So the first thing I'm going to do is go back and kind of dissect the problem, break it down into pieces. For that, I'm going to pull up a different color pen just so that we can be on the same page. Okay, so in the first sentence, it tells us that Kyle purchased a padlock. So the object, kind of the scenario here is that there is a padlock. You've probably used a padlock before in your lifetime to lock up a bike or to lock up a scooter, something like that. Maybe lock up your suitcase. So we know what a padlock is, and it's telling us that this type of padlock has a resettable combination. So this is a combination lock. Now, most of those combination locks have little dials, and you can spin and you can set a number in order to unlock the padlock. So that's what we're dealing with here. We have a padlock. I could even draw a bit of a picture here. So if you think of this as being the face of that padlock, right? And then usually there's going to be digits, kind of wheels that you can spin and rotate for setting up your different digits on the padlock. And so, for example, I might spin and rotate and have a 0 in the first position. I might have a 3 in the second position and a 9 in the third position. So this is just one example of a combination that could appear on the face of a combination lock. Okay, and it tells us that this particular resettable combination uses 3 digits, just like we've drawn, and it's 3 digits that range from 0 through 9. So this digit here could be anything from 0 through 9, right? And the same is true for the second. So this could be anything from 0 through 9. And the same is true for the third. This could also be anything from 0 through 9. Okay, and there's just one more important piece of information that they're giving us. They tell us that a digit may be repeated in the combination. Why is that important? Well, if it were not possible to repeat a digit, then that would affect how many different possibilities I have. So for example, if I had a 5 in the first position, and I could not repeat that 5, then instead of being able to use anything from 0 to 9 in the second position, I would have to remove the 5 from that list of possible digits. And so I would have 0, 1, 2, 3, 4, not 5. And then I would have 6, 7, 8, and 9. So there would actually only be 9 different possible things that I could use here. And maybe I use a 6, let's say. Okay, so now there are 2 digits that have already been used. I cannot repeat them. So in the third position here, I cannot use a 5, and I also cannot use a 6. So now there are only 8 possible digits that could be used here because I could not use the 5 or the 6. Okay, so in this case, though, in this problem, it tells us that a digit may be repeated. So we do not have to worry about limiting the digits in that way. We can use a 5 in the first position, and we can use a 6 in the second position, and then we can repeat the 6 if we want to. We're not limited by only being able to use each digit once. So that means that there are 10 different possible digits that we could use in the first position. There are still 10 different possible digits we could use in the second position, and still 10 different digits that could be used in the third position on this law. Okay, so hopefully we have kind of broken this down. We've thought carefully about the information they've given us, and I feel like we understand it pretty well. So now let's focus on the question that they're asking, because that's really the most important part of the problem. They're asking us to answer a question, so we better understand that question. So the question says, which expression, and these are examples of expressions in your answer choices here. So which expression shows the total number of possible combinations for the padlock? Okay, so let's think about what that means. The total number of possible combinations. Well, possible combinations. Let me just kind of brainstorm a few possible combinations. So we could have a 4, a 2, and a 0, right? So that's one possible combination. Another one might be a 3, a 1, and a 1. Because remember, digits may be repeated. We could have 8, 8, 9, right? So there's really very many possible combinations for this padlock. How do we figure out the total number? The total number. Is it 5? Is it 10? Is it 100, 1,000, a million? What is the total number of these different possibilities, possible combinations? So to answer this question, we really need a systematic and methodical approach. And one concept that you would learn if you were studying through some math teaching curriculum for the HiSET exam is this idea of combinations and determining total possible number of combinations based on events. So if you think about this, there are really 3 events that take place. The first event happens when I set the first digit. So that's an event. And then the second event happens when I set the second digit. So there's the second event. And then the third event happens when I set the third digit. So this is a situation where there are 3 different events that are taking place. And we're looking at the total possible number of combinations for these 3 events. And we know that in the first case, there are 10 possible outcomes here, 10 possible digits that could be put into that position. The second position has also 10 possible outcomes, and the third position has also 10 possible outcomes. So if you want to think about it, if you were trying to list every possible outcome methodically, for each of these digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, you would need to use every one of these possible combinations and also every one of these. So we're talking about this idea of for each, for every, right? And these are keywords that we see when we're thinking about the concept of multiplication, for each, for every. So for each digit in position 1, there are 10 possible digits in position 2, and also 10 possible digits in position 3. So if we think about this idea of for each, for every, this is the concept of multiplying. Like if I say there are 5 apples for each of the 4 students, right? So there are 5 apples for the first, and 5 apples for the second, and 5 apples for the third, and 5 apples for the fourth, for a total of 20 apples, because we would take the 5 that are being given to each times the number of students. So 5 times 4 is 20. So this idea of having for each, that's a concept that requires multiplication. Okay. So we're going to be multiplying for each possible outcome in the first position. We're going to multiply that times the possible outcomes in the second position, and then also multiply that times the possible outcomes in the third position. So in order to find the total number of possible combinations, we would need to multiply 10 times 10 times 10. Now, in this case, we don't actually have to do that multiplication. They're not asking us what is the answer, right? They're asking us which expression shows the total number of possible combinations. So let's look at our expressions here. Starting with expression A, this is an example of an exponential expression. So there is a base, the base is 3, and then there is an exponent, and the exponent here is 10. So what does that mean, a base of 3 and an exponent of 10? Well, when you have an exponent, the base is the number that's being multiplied. So I'm going to be multiplying 3. And the exponent tells me how many times I'm going to multiply the 3. So I'm going to multiply 3 times 3 times 3 times 3. I'm going to keep doing that for a long time, right? I'm going to keep doing that. And the number of times that I'm going to do that is 10. 10, that exponent tells me how many times I'm going to multiply 3. So is that the same as our solution to this problem? No. In this case, we're multiplying 10, and we're multiplying 10 3 times, but we're not multiplying the factor 3 10 times, right? So that's kind of got it backwards. So let's look at the second expression here. So in the second example, we have, again, an exponential expression, but this time the base is 10 and the exponent is 3. So it's kind of the opposite of this situation. Instead of multiplying factor 3, we're multiplying the factor 10, and we're going to multiply the 10 3 times, right? So I've got 10 and 10 and 10, 3 factors of 10 being multiplied. So this is the same as our solution to this padlock problem, right? We do need to multiply 10 3 times in order to solve this problem. So B then is going to be the correct answer. So we've identified the correct answer. The correct answer is B. But let's look at the other possibilities and see why they are not correct. So we said A is not correct. It kind of had it backwards. E is also not correct, because notice we do have 3 10s, but instead of multiplying, what they're doing there is adding, right? So we're not trying to add the combinations. It's not that there are 10 plus 10 plus 10 total combinations. What we're doing is we're multiplying the possibilities for event A times possibilities for event B times the possibilities for event C to get the total number of combinations. And so that's going to be 10 times 10 times 10. So it's not a problem involving addition. The same is true with C. In this case, they're using 10, 9, and 8, but again, they're adding. And we already know that this problem involves the idea of multiplication, that we have for each position, 1, we have 10 possible digits that could be in position 2 and 10 possible digits that could be in position 3. So this is an idea of multiplication, not addition. Now let's look at possibility D. So this one, when you see numbers put next to each other using parentheses like this, that does mean that they are trying to multiply those numbers together. So this is multiplication. They're multiplying 10 times 9 times 8. Now remember, I told you if a digit could not be repeated, then that would limit future possibilities, right? So if I were to put a 5 in the first position, and now I can't use the 5 in the second position, now instead of 10 possible digits for position 2, I would only have 9, right? And then again, if I were to repeat and use a 7, let's say, in position 2, so now I can't use a 5 or a 7 in position 3. And so D would be the correct answer if the problem were a little different. If the problem said a digit may not be repeated, then D would be the correct answer. But in this case, the problem says that a digit may be repeated in the combination. So therefore, B is going to be the correct answer here. So let me just stop sharing here. Okay, so I hope you found this video helpful in better understanding combinations for the HiSET exam. And again, my name is Andrea with the Simpson County Literacy Center, and I hope you'll look forward to future videos as we go through some of the other sample math problems from the HiSET website. Have a great day.